Mike was, along with Peter Pitsis, were the first engineers that we dealt with in the early 90s when we had to meet the Safe Drinking Water Act. They were with Dufresne Henry at the time. And I apologize, your name again?
Dan Tingley.
Okay, and you are with?
Emery and Garrett.
Emery and Garrett, so trained professional right there. Peter Pitsis, Underwood Engineers. I'm Ken Jakes. Rick Cross, John McKenna, Bob Thorpe, Superintendent in Cotton, Cleveland, who is a stakeholder in all of this because of Cleveland Corporation and its and Colby Moore. So we invited Cotton to listen to this because I ran into her not too long ago. We had a little conversation. We had to get together and share some ideas, and I think she's got some information she'd like to share later on. So,
Ken, I believe Randy's going to get Andy Goff on Zoom. So
great. When you get him, you let me know.
Andrew, I'm trying to get you to join the meeting, but I can't connect to the internet, so you might have to just be on the phone, okay? All right.
Can we put in here a mic so that everybody can hear? Because everybody has to be able to hear what he says.
Okay?
I don't think your mic is on. If you just want to press the button in the middle.
there you go.
See that green light? That means it's on.
Pete, you're the same thing.
So is Andy someone we need to listen to immediately, or can he listen to some of this meeting?
No, yeah, he'd like to listen to the meeting.
That'd be great. That'd be
Yes.
great. Okay, so what I'd like to start with is Mike Metcalf, who was able to get the analysis of this broad paintbrush that these folks drew across this area, and maybe just give a synopsis of what conclusions you drew from that. And then Emery and Garrett could give some ideas to what they had for information. And this is regarding Colby Point specifically at this point.
Not regarding Little Lake Sunapee.
No. Not
That's kind of what I looked at more in the last go-around.
I understand.
Okay.
I understand. But I still
Yeah.
remember your comment that for bang for your buck, Colby Point probably wouldn't be the place I'd be investing money. So Little Sunapee has a surface water supply. I mean, I think we have a good idea, based on your estimates, of what that would cost and what that would entail. That seems to be,
That's a big nugget.
that's a big nugget, yeah. So if you could give your comments and whatever you and Peter have discussed, that'd be great. And
Yeah, I'll talk about the big picture. Yeah, right, yeah. Okay, so
That'd be great.
you want, I can give just a little background.
background's good.
I don't know how much background you want, but in the early,
That's on.
can everybody hear me? Oh, I got a lot of nods, okay.
Peter, turn that one on too.
And Andrew, you're there too. Okay, so in the early 90s, the precinct had to face the surface water treatment rule, and they had a surface water supply that was unfiltered and untreated, and they either needed to treat that or find a new supply. So we looked at the options back then. That's when Pete and I were with Dufresne Henry, we're the consultant for the precinct, looked at groundwater options around town, and really Colby Point seemed to make the most sense. It had been identified by the hydrogeologists that we were working with at the time from a company called DLMAR as a potential esker, which we can talk about whether or not it is an esker, but an esker is a geologic formation formed at the bottom of a glacier that brings a lot of material, deposits it, and it can, depending on where it is in relation to the ice, can be a good deposit for groundwater. So we proceeded to recommend to the precinct that they go ahead with Colby Point as an option. We had ultimately 6 wells. Is it 6 or 5?
6.
Yeah, 6 wells installed out there. 3, if you're familiar with the point, sort of 3 on the upper part of the point, let's say the ridge, and then 3 closer to the water, about midway in the point as it starts from the shoreline and heads out to the tip. And those aren't prolific wells, but they certainly were in the order of, I think, 50 to 120 gallons per minute each, roughly around that much. And combined, they more than met the average day demand that we needed to meet for the system, although that increased much in the next year or two, is my recollection. But so those wells were put in. They're manifolded together in order to meet the requirements of the Clevelands, those wells are all below ground. You can't see them. If you go out on the point, there are just manhole covers where those wells are, which makes it a little bit more difficult to access them and maintain them, but that was part of the deal. And then there's a pipeline, there's a buried pipeline and a buried conduit that takes all the electrical wires out to run those, and that all runs back to a pump station, which is across Little Sunapee Road, sort of tucked into the bank around the corner. It was specifically done that way to make it less visible. So one of the charges on this whole system was to make it invisible as much as possible so that it wouldn't affect the recreational use of the point. So that's sort of the history of how we got there. And at the time, we did look at treating Little Lake Sunapee. We looked at very similar to what Emery and Garrett has done more recently, which is to sort of look at the possible well sites all around here. And I think what you're going to hear from Dan, and what's kind of obvious, is that we're on a hill. And this is a geologic formation, and there isn't a lot of great potential right here in New London. It's sort of out away from us for the most part in terms of sand and gravel aquifers. And then the more recent analysis that we did, we got Emery and Garrett involved because Colby Point had been losing production. You know, it wasn't producing as much as it used to, even with Barry Miller, who is the well maintenance guy who is supposed to be here, I guess. He's on his way. So he tries to maintain those every couple of years, every 3 years. But even at that, they've reduced in capacity. So the question has become, what do we do? Do we add more wells out there? Can we modify the wells? Can we do something? And that's what we looked at, and we had Emery and Garrett look at that. And basically what they started to find looking at all the data is that it's an esker, if you know what that is, that's a good geologic formation. It may not be that. It may be a different geologic formation that looks like an esker, but there's a lot of fines in that, which with a sand and gravel well, you want coarse material. Coarser the better. If you have a lot of fines, the water doesn't flow as fast through it. It's hard to get it out of the ground. That fines can plug up screens. You got to make the screen smaller. So what they were finding was that Colby Point, while it has been adequate and has done a good job, it may not be a geologic home run in terms of ability to develop a lot more supply there. So I don't know if that's a good lead into Dan, or if you'd like to hear more.
No, I think that's accurate. I think it's important to mention, and most people have heard me say this before, that it was the best of the not great options that we had available to us in the mid-90s. And we knew going in that there was a finite amount of water available from that site based on the pump test that was done at the time of the development of the field. So the loss of efficiency was already in front of us. We knew that going in, but it was still the best option that was available to us.
Very accurate, because, you know, we looked at treating the existing surface water supply. We looked at other, you know, we tried to look at all the options, look at the capital costs, look at the operating costs, and do what we call a present worth analysis to bring those costs up to the same year so that you can look at and say, what's the present worth of a pump station where you have to pump every year versus of a surface water source where you don't have to pump every year? You figure that out so that they're equal. And based on that, Colby Point was the best option that had the most supply close to the system, which is always a major consideration.
Ken, I'm just really confused about the dates. The mid-90s, 1990s can't be right, because my dad died in the mid-90s, 1990s. I thought you were talking more like 60s or 70s.
No, the
No,
system
no.
came on in 1995. It's 30 years old next year. Yeah.
Oh, so
But the analysis prior to that was done in the early 90s.
Yeah, I feel like the report phase might have been 91?
Yeah, it was the early 90s.
91, and then it would have been, we'd already decided on the Colby Point, and then we started working with your father and your mother just to talk to them about the thing and what it would be like and what were their requirements.
That was well before the field or any stuff was put
Right.
in the ground
And the special meeting was in '93.
to raise the money.
Right.
Yeah.
And by then, we had pretty much everything in line.
So The other thing worth mentioning, Mike had said we looked at surface water, and, at the time we were using Morgan Pond up in the Gow Forest. As part of our analysis, there was discussions with the state of New Hampshire regarding treating Morgan Pond. And at that time, the state was adamant that we were not to use Morgan Pond as a primary source because it was the beginning of the watershed, and there were years that there was no water in Morgan Pond. And their comment was, doesn't make much sense to treat something that may not be there. And so we couldn't count on it. So that's why there was a look at Little Sunapee as a surface water source, but that added another dimension because now you've lost your gravity feed to town. You'd have to have pump stations that would take Little Sunapee's water and move it up hill. So that just, a lot of people have said, well, why don't you just go back to Morgan Pond? It's not an option, so.
Yeah, Morgan Pond also has high organics, and organics, and you would have to chlorinate, disinfect that water, and when you combine organics and chlorine, you form something called disinfection byproducts, which is a regulated parameter. I'm facing that in another place where I happen to live, and it is, it's a big nugget. That means full treatment in order to get those organics out. So it would be, not only is the safe yield not necessarily there, it would not be an easy source to treat.
Yeah, we were chlorinating that at the time, and I know that the state was constantly looking at, I believe it's the byproduct trihalomethanes, that they were concerned about, and we had a lot of tannins.
I was going to say, you also, I remember, had a lot of colored water complaints.
Special water.
Yeah, special water, yeah.
So, anyway, thank you.
Yeah, I'm happy to add whatever is necessary.
Yep.
That's sort of the overview.
To jump into. And then the study that we just recently did had 3 parts to it. We're looking at what could we do to Colby Point, could we take water out of Little Sunapee and use that as a supply, and then look at additional groundwater supply. So those are the 3 major things that we looked at recently. And Dan did most of the work for the looking at the Colby Point part of it, and then looking for an additional supply. So I'm going to turn it over to Dan, and he'll fill you in on that part.
Thanks, Peter. Yeah, so Mike did a good job summarizing the hydrogeology out on Colby Point. Essentially, you have a fairly fine-grained matrix. The sand is fine. It's not a whole bundle of pebbles or cobbles that you might expect in a normal esker system, which is generally a high-energy environment from our standpoint. So whatever you want to call it geologically, could be an ice crevasse filling or an esker. Either way, it's got a lot of fine material in it, and fine-grained material tends to be harder to maintain over the long run, which is why Barry Miller has to keep coming in and try to redevelop the wells. But essentially, the aquifer is limited in its capacity to transmit water because of the fine-grained nature of it. And the other serious limitation is the amount of saturated thickness. And if you have fine-grained material and you have 100 feet of saturated sand, you can draw down the water in a well and you can drive more water to it. But out here, we're pretty limited to 30 or 40 feet of saturated thickness, and that's borderline for good material. And the fact that you have fine-grained material coupled with that just makes it that much harder. You have to rely on gravity to drive the water to your well after you suck the water out of your well. It's driving more water back into it. So that can't really happen because of the fine-grained nature of it, and you just can't induce enough drawdown in the well because you just don't have the thickness available. So for those reasons, efficiency, you've mentioned the word efficiency a couple times, it's all about efficiency. Can we somehow increase the efficiency of wells on Colby Point? And in our report that we put together, there's a few options for doing that. One is replacing the wells with larger diameter wells. You'd make a bigger surface area for more water to leak in. Fairly pricey option, but you can do it. You could put in new wells, but you've already got 6 large diameter wells, and that's a lot of wells for a small area, and that's testament to the fine-grained nature of the material out there. And those are the 3 biggest alternatives you have to try to get something a little more efficient, so you can actually drive more water to the formation. There's apparently this fine-grained material also is a real barrier to flow from the lake. Ordinarily, like Mike said, if you have an esker-type setting in the middle of a lake, you have almost limitless water. You have a really good hydraulic connection, we call it, between the aquifer and the surface water. In this case, that's not the case. You draw down the wells, and you just can't pull out the water fast enough because of the fine-grained nature of the matrix of the aquifer, and probably some of the bottom sediments of the lake too. So really the only alternative to wells that are drilled vertically with say you have 30 feet of water, you drill down to the bottom, you put in 10 feet of screen, which allows water to leak into the well so you can pump it out. The other alternative, which is our option 4 in our report, is to put in a horizontal well. They actually have drilling technology now that will allow you to drill horizontally across an aquifer down near the bedrock surface, and that allows you to take full advantage of your limited saturated thickness of the aquifer. So you put your screen down low, but it's much, much more expensive to install. You have to drill horizontally, and then somehow you have to construct a horizontal well down near the bedrock surface. It gives you much more opportunity for leakage over a big area to provide more water. To my knowledge, and Andrew can confirm, maybe Randy too, we don't think there's been any permitted in New Hampshire, a public supply well with a horizontal screen. So it'd be fairly new, definitely be much more expensive than your standard well drilling operation, but that's probably the best alternative at this limited geologic site for getting more water. So it's a possibility, and it might be something that's worth looking into. We'd have to get prices from a horizontal driller and really get a realistic assessment of how that would work and what it would take for pumps and electrical, and the engineers would have to get involved with that. But that's essentially, from a hydrogeologic standpoint, everything's limited by that depth and the fine-grained nature of the material, and horizontal drilling allows a possible alternative. And I'd say it's somewhat in the experimental end of things. They have done it in different places around Canada and the U.S. effectively. So it's a little bit it's not routine, I'll say. It's more of a unique application of a fairly new technology that will allow you to do that.
So DES's experience with horizontal wells hasn't been good. They tend to have bacteria, a higher probability of bacteria presence.
Interesting.
Drawing in,
Yeah.
but I'm sure.
Are those under rivers or lakes or something? Or why would you say there were higher bacteria? The reason for that?
I'll let Drew talk about that when he speaks, but I'm not the well guy. I'm just the engineer, so. So and Peter wants to know why our experience hasn't been good, and is it under surface water?
Yeah, can everyone hear me okay? Sorry, I couldn't be there in person. It's Andrew Koff, DES. Everyone can hear me okay?
Yeah.
Put the mic right in.
Yep, good.
Sort of. Okay. Okay, with horizontal wells, I don't have any particular personal experience with them, but I know in talking about that idea that was brought up from Barry Miller and also in the GZA report about horizontal wells. I think, I'm not sure if it's bacteria, although they're harder to maintain and clean. So there's some technical challenges with horizontal wells that make them less favorable. At this point, to me, I think the starting point was something looking straightforward at additional wells in the existing well field. More traditional wells would be the obvious next step from my perspective. If the district was looking to add additional capacity to those well fields to replace what is a diminished well yield. I guess I've been hearing a lot of talk today in this meeting about, in general and in the reports I've seen, that well yields have gone down over time. But I have not seen a lot of specifics related to the individual wells, whether that's water level monitoring. I have seen Barry Miller and his reports that he submitted. I think the most recent report we had of a well cleaning was from 2013. That was sent in to us by the district. he did provide us some specific capacity measurements, which are a yield per yield from the well per unit of head loss during pumping. So there were some specifics that Barry Miller's provided throughout the years about what each individual well capacity has been, but it's pretty limited. So I guess from my perspective, I understand the wells the formation has limitations, it's fine grained. The wells have limitations, they've lost capacity. They might not regain it all back, but I have not seen really an investigation of which wells specifically have lost the most capacity or yielding the least amount of water currently, and where there are opportunities to develop additional capacity in parts of the aquifer. So I think there's opportunity for the district to investigate the well field with more detail, doing something like a camera analysis, downhole camera of the wells to actually look at, what does the well stream look like? Is it clogged with iron? Is there a redevelopment, a more aggressive type of redevelopment of the wells that could be done? I'm not exactly sure what Barry Miller's been doing, but I think typically they go in there with the cable tool rig and they surge the well. They go in with this device and it surges the well screen and tries to pull out all that accumulated material on the screen. But could they do sort of a chemical treatment or other well redevelopment that might help increase the yield? So these are some options with a little more. It's pretty easy to sort of write off the whole well field. It's not a great aquifer. It's shallow. It's fine grained. It's not great. Let's look elsewhere. But you have a lot of value here in this well field. It's been permitted. I guess the point I tried to make in my letter, it's been permitted up to 750,000 gallons per day. So in terms of a state perspective, you have the ability to pump that much without needing to obtain a large groundwater withdrawal permit from us. So you could add wells into the system that you currently have to supplement the existing wells without a lot of additional permitting work from my side. Certainly there's expenses. It's going to cost money to install a new well, figure out where to put it, pipe it in, all that. But from a state permitting perspective, it's pretty straightforward.
It might be.
So those are some of my thoughts.
Thank you, Andy. It might be worth having Robbie speak a little bit about, because he knows what Barry does on a regular basis out there, and that might clarify some of the questions that you have mentioned.
That's exactly what Barry does. He comes in and, he's real careful about how he cleans the well, because if he gets too aggressive with the pumping and surging, he tends to draw in more fines than he started with. And so he can typically bring back, anywhere from 3 to 4% potentially, of what we lost, from the previous cleaning. So it's not a great scenario. And he's going to be here shortly, and he may have some other suggestions about cleaning them. He does clean the well screens with acid and flushes, replaces any broken parts and whatnot, that the pump itself might have. He does rebuild the pumps, but the meat of it is it's the fine sands that are causing the problem. And I'm not sure whether or not he could be more aggressive with the cleaning than he is, again, because he's pulling in a lot of fines.
But he also does that each well every 3 years.
Each well every 3 years, yeah. So he does a set of 3 every 3 years.
Yeah, he does 3 wells one year, 3 wells the following year, then he does the turbines on the off year.
Yeah.
And back to so it's every 3rd year they get serviced. And that's the recommendation he had given us, and we've been going with that.
Yeah, we tried to push it out, because it's a lot of money to have him come out. And, we did that at one point in time. I think we went 4 years, and he said, no, we got to go back to 3 because it was just, needed to be done sooner.
I think too, that, Andy, it's worth mentioning that if I remember correctly, when we started with Colby Point, the 750,000 gallons a day was based on the pump test that was done on the field. But I know Barry recommended that we not operate at that level for fear of short-circuiting the entire well field. And I know from day one, it's been throttled back, and I think we started in the 650,000 gallon per day. That was our threshold, and we would not go above that because of exactly what we're talking about, losing the efficiency. It would just make the efficiency of the wells happen sooner. So I vividly remember that, if I'm remembering right. So we've never exceeded that, even from day one. But
Yeah,
have seen
and
them-
that's very typical. Typically, no one wants to be pumping their well field at the total capacity, because for those reasons, you would be exerting undue stress on it. But, so that makes a lot of sense, and that's a normal way to operate. But I guess at this point, you could develop additional wells to get closer to that capacity. Not saying you need to get back to 750,000 gallons a day, but you could put in an additional well, maybe a larger diameter well, that could provide you an additional, whether it's 50 or 100,000 gallons a day, just to supplement the existing wells that you have. So the goal might not be to get back to that, to get to 750. That's maybe not an obtainable goal, but you could add to what you have now, because from what we've heard, there's not enough capacity from the current well field. Limited capacity at times.
Theoretically.
Theoretically.
I also think that in the discussions I know that we've had with Barry, and correct me if I'm wrong, that one of the concerns has been if you added another well to the field, would you then be just robbing Peter to pay Paul? Would you diminish the ability of the other wells to produce the volume that they're producing now? This has all been part of the conversation going forward, because, we're trying to get as much information as we can, and that was put out there, so.
Right, and that's where monitoring water levels throughout the production wells or any other monitoring wells, if you have other wells out there that aren't being pumped, if you had a water level monitoring network to look at what are the levels in the wells while you're pumping, and when you're not pumping, how quickly do they rebound? You might be able to start assessing that potential. Are there places where you are having more drawdown, or are there other places where you're not? So as the wells lose efficiency over time, they don't actually reach out as far. So the water level in the well itself might be low, but that's because the well isn't well connected into the aquifer anymore. So you might actually have plenty of available water nearby from an inefficient well like that. That may or may not be a problem, and that's exactly why I'd recommend to you that you look at the well field with more detail than I've seen, which is to actually go out and monitor water levels out there to determine what's going on out there right now with these wells individually. I've seen total pumping rates per day, because you can measure the rate that's going into the cistern or the wet well that you have there, but I would also be interested in if you could measure the rates from each well individually, if you have a way to do that. That would be something.
That would be great. That would be great if we could do it. You're
right,
talking about something that would be a lot of money and time to do. I'm just saying, these were all considerations, but you could not, a meter on every well? Is that what you're talking about? Or you run each one individually and measure it at the pump station?
I don't know. This is information that would help us make this decision that we don't have right now in terms of assessing the well field. These are normal things that when we're assessing well fields, you look at pumping rates and you look at drawdown and the water levels. So
think it's.
Right now, I feel like we're flying a little blind here in this conversation because we don't have those two kind of core fundamental data points about this well field. So it's a funny discussion. I just want to point that out.
Sure. Yeah, I can basically ditto Mike. There's a lot of limitations on what we can pump one at a time and what we can measure water levels in. All those things were considered, and we were hoping to get more data, but it just wasn't feasible, given the existing setup. The other real limitation out there is available space. There's really not much more room for another well on the footprint that we're working on. So there's the southwest quadrant of this area it's more or less empty when you look at a map of all the wells, but they're very fine-grained materials there in the test boring, so I think we stayed away from that area right from the start. They never put a well there, so I think we're pretty limited on this footprint where we can go, but it's not impossible. I mean, you could always put more wells in, but whether you're getting any more bang for the buck, that's tough, because they are so close together. But I concur with you. It'd be nice to have more water level data. As I understand it, there's no monitoring wells in the production well, right in the area of the field.
Yeah, we have transducers in each well.
In the well, yeah.
We do, and they're monitored. But pulling data from the SCADA system is more than cumbersome.
Yes.
You can keep scrolling back, but I mean it takes so long to go back through to get anything. Just because it's a rudimentary SCADA system, basically. You can't really search it.
You don't have any other monitoring wells out there? Right?
There are some that were left, some 2-inch wells.
And you don't do any monitoring of those?
No.
Yeah.
I mean, I'd be hard pressed to find them.
Yeah.
Okay.
I think I've stumbled across them by accident.
Yeah.
I know where 2 of them are, I think.
Yeah, I think there were, in the original 95 report has other monitoring wells that were out there. But so you do have the transducers in the wells, but they're just you're not able to download that information?
Well, the information comes to us real time through the SCADA system. You can scroll back through on the chart, but it would take a while. I mean, I could talk with A&D Instruments and see if there's a way to get that information out, in some type of file, but I'm not sure that's feasible either. But I could ask that question. But as far as pulling that data, so that you can look at it and discern what's going on out there, it would be a huge project for someone to sit there all day long and just keep clicking back and printing the page.
You're in unfortunate company there. So many systems have access to water level data and cannot record it and pull it out when they need to. It's very maddening for hydrogeologists like me, but it's not atypical, unfortunately. So there may be a way for them to pull the data out, but it always costs more money and more software, basically, to pull it out and put it in an Excel spreadsheet. And it's probably worth doing. At some point, it's one of the many items that would help give us a little more information, I'd say, from the SCADA system. In the monitoring wells, I don't think, we were out there in the middle of the winter when I was out there, and we didn't run into any of those wells, but if they're out there, it might be worth testing them and seeing. I think one of the issues that we had with, even if we get water level data in individual wells from the SCADA, we have to know that which wells were pumping at that exact time, and there was only 1 meter in the pump station that did cumulative discharge rates, I believe, at the time. So we're like, how are we going to know which well is pumping how much?
Right. The meter at the pump station just meters what water is being pumped out of there by the vertical turbines to the system. So there's no meter on the well line, and in order to do it, and I'm not sure there'd be room with all the yard piping at the pump station, you'd have to put it in some sort of vault,
Right.
And a mag meter of some sort.
Right.
And that's a lot of money too, just to.
But it doesn't really make sense because you have water coming in on your raw water line, filling your clear well, and you're pumping out of that. So it's really, you're measuring the same volume because your clear well really isn't changing much in volume-wise.
Right.
So during the day, water in is water out.
I mean, we could run one well at a time and, measure how much water is in the clear well and then, calculate it that way. It's not very accurate, but it could be done.
Something, yeah.
And then I'll just add one more thing, and I think we talked about this at the last meeting, is right now there are easement restrictions on the property on what you can do out there. There are also limitations with the infrastructure that's there, in the sense that if we put an additional well in there, there's not additional conduits to run wires out to it. So you would have to, install additional conduits below grade to run out there. If you had all those, just say you put in 2 additional wells and you had 2 additional motor starters in your pump station, then what does that do to the electrical feed to the building? Does the electrical feed need to be upgraded? And then that translates into, does the backup power, the generator there need to be modified? So when you add in, just saying add in a well, sometimes it sounds a lot easier than it is. There's a lot of infrastructure that might have to go along with that, and that comes in with cost. So,
And it gets you back to the question with Emery and Garrett had indicated that, for the kind of money you may have to spend on Colby Point, maybe you should be looking at a supplemental source elsewhere, which I think were bedrock wells, is what you would, but again, with the paintbrush effect, it doesn't tell you the ease of putting in those wells. It just tells you that's a possibility for water. The precinct owns no land in New London. And so you'd have to start with that by going to find properties. Some that were identified, I think, belong to the town or have conservation easements on them. And we'd have to look at whether or not there were restrictions of development with those conservation easements. So there's a lot of unknowns as to where, and you'd still be sticking a prod trying to figure out where you're going. I know that we could do some fine tuning on that. So you can understand our quandaries. I mean, Colby Point is there, it exists, it's been a good viable source based on what we knew about it from day one, and it's, my personal feeling originally was, if we could go to that and enhance that, that would be better off for the precinct. The question then becomes, how much water are you going to get out of that? Is it just supplemental enough to, get you through the next 10 years or so? There's a fair amount of pressure on the precinct right now for water, and you want to make the right decisions.
I'll mention, ultimately, if you do need more water and you want to go above the 750,000, then it becomes a significant permitting issue. I think Andrew will agree to that.
With the state.
With the state,
Yeah.
yeah. To go above and beyond the permitted production volume, which is 750,000 a day. If you increase above that, it kicks in a lot of new regulations. Yeah.
So
Redo your permit.
would the state have a comment on if you were to try to enhance Colby Point in the existing easement footprint, and you were able to draw 750,000 gallons of water per day, would you still be permitted to do that, even though the field itself could probably produce more than that? Because as I was saying earlier, we have a 750,000 gallon per day threshold, yet we've never pumped at that level. You understand what I'm saying is if you could go to the 750, could you actually have a higher level but never really go there without additional permitting?
You wouldn't be permitted for more than 750 unless you put in a new application and, like they said.
That would be for withdrawal, though, 750,000 gallons of withdrawal per day.
Correct. You can get up to that much now under your current permit.
Yep.
So you could put in more infrastructure that you ultimately could pump more than 750, but you just can't pump more than 750.
That's what I'm asking. So 750 would be where your cap, yeah. Okay.
I might say that that's like a theoretical max, right? I mean, you've never actually pumped that amount of water off. That's the theoretical max that you can get based on the pump test.
From the pump test, yes.
Yeah.
That's
So
what,
I'm just saying, the idea of returning to that amount, you've never actually pumped that amount.
I'm glad you're here, Barry, because there's so many questions for you. It's unbelievable.
Barry's going to fix it all.
So Barry Miller was the gentleman that unfortunately was a little bit late, but I get that, that's fine. Thank you for making it. Barry does all of our maintenance with the well field and the pump station, other than the electronics. And he's been a great asset to the precinct over the years. You're not getting older, though, so that works out okay, right? Just to summarize a little bit, we had comments from Emery and Garrett regarding the field itself, and Mike Metcalf gave some history on the field starting from the mid-'90s. And we were talking with Andrew at the state at DES with regards to potential options in the existing footprint out there. And one of the things that Andrew raised for questions was our capability to measure the capacity of each well on a regular basis. And Robbie didn't seem to think we had that capability at this point in time. There was also some questions on what is the maintenance that you actually do to each well every third year. So if you wanted to elaborate on that, it would probably be beneficial. We were just there 15 minutes ago, so. Yeah.
So the maintenance that we do on the wells every 3 years would be to take them out of service and mechanically surge them and try and restore the lost capacity that happens because of the small sand and silts that migrate towards the well while it's being pumped. As far as the testing, we could test those wells individually, but we have to set up at the pumping station on the other side of the road from the point, and we could flow them out there and test each well individually. So
It was mentioned that maybe we could get A&D to look at our SCADA system and see if there's anything that we could download there that might give us an idea as to what's going on with each well on a regular basis.
with the water levels, you can use the transducers to monitor the water levels and see if anything's going on with that, so. And you probably see them slowly change because of that clogging that naturally occurs with the small fines in the formation migrating towards the well screens, so, yeah.
You had initial comments to the board and Robbie some years ago, and we talked about it a little bit. And Garrett mentioned it, and Andrew talked about it. A horizontal bore out there.
Mm-hmm.
Doesn't sound like that's cutting edge across the state of New Hampshire.
You're saying it doesn't sound like it's cutting
It didn't
edge?
sound as though there's a lot of those out there, and
No.
okay. So that's something that it takes place in other places that you know about that technology. And you were mentioning it because you have experience with it, or?
I've seen a little bit of it, but there is some nearby that you could maybe look at or get an idea of, right at the power plant in George's Mills.
Has a horizontal bore?
Yeah, we put in vertical wells there originally.
Right.
And those clogged up over time, or they needed more water, and they set up on the solid ground and did a horizontal
They have an
or angle
well, but it's
angle
not,
drill.
Not a horizontal.
So,
They do have an angled well. That's one of the only ones in the state that is in non-vertical.
That's
Well,
Andrew Koff from
okay.
DES.
oh, okay.
So Andrew was just saying that that's not considered a horizontal well, it's a vertical angled,
Correct.
an angled well, yeah.
Yeah, I mean, that, I guess we could, the initial take on the horizontal well was that it's too complicated and the engineering of it's pretty challenging and it's not really the right application here. Potential for bacteria problems due to the proximity of the surface water here. It may not be the right setting. Could you explore an angled well? Possibly, and we could look into that more. Those would be something we could consider. But I think just normal drilling of vertical wells is also seems to be the most obvious option from my perspective.
One of the things that I had mentioned just before you got here was that, and I know we've talked about this, if you were to add a well or two to the field, I'm pretty sure we had conversations about could that compromise the ability of the other wells to produce?
Yeah, I would think you'd have to space them as far away from the other wells as you could, you know. I'm sure Dan with Emery and Garrett could tell you a little more about that.
He was
but-
just mentioning, go ahead again, Dan, if you want.
Yeah, I can elaborate a little. Yeah, like you say, it'd be nice to spread them out further. The footprint that we have to work with is pretty limited, and the test borings that were available early on from DLMR and I think other companies just show there's some really, really fine grain areas. I mean, where the wells are the coarsest of the fine material, but there's other areas that are just fine sand all the way down. And ordinarily, we just stay away from those areas because of the issues with redevelopment. And so there's not many places left on the existing footprint. And it's not to say there's not something north or south of that on the peninsula. It's quite possible that there's some coarser lenses mixed in. But from all the test borings, and there's quite a few over the years of test borings out on the peninsula here, the best we can tell from all those records is that it's very fine. In the areas where there are no production wells, it's exceptionally fine. So people stayed away from it. We just didn't put a well there. Whether we could put a well there now, it's possible. There's lots of technology now for different pre-packed well screens and all sorts of things. It's just, it's leaning towards the horizontal drill. It's just a little unorthodox and probably, I would say definitely more, riskier. You just have a higher level of risk for the reward probably, but certainly possible.
So Barry, one of the other things we had spoken about in the past was the possibility of upsizing the wells that we have out there, at least some of them. Is that a viable option, or is that just?
It's something you could take a look at, we could take a look at. The whole reason I was suggesting the horizontal well is to increase the linear foot of open screen area exposed to the aquifer. With the vertical well, you're limited to 6 or 8 feet of screen in each one. With the horizontal well, you could put, several hundred feet in if you wanted. And so you could kind of do the same thing with, enlarging the well diameter. You get more open area per foot with a larger diameter than the smaller. So that's something we could look at, but I'd like to have some of my own formation samples to analyze and look at what we could do with that.
Okay.
Barry, do you know what diameter they are now?
10 inch.
They're 10 inch, okay.
Yeah.
They're 10 or 12, so, okay.
I think they were 18-inch boreholes, and they put artificial gravel pack
Sure.
between the 10-inch screen and the 18-inch borehole, and then removed the 18-inch
Yeah.
casing.
Yeah. Thanks.
So is there any consensus on where we should go with this thing if we were going to start looking at Colby Point? I mean, we could do that, if everybody felt that it was advantageous to do that.
Maybe a geophysical line.
Yeah. Yeah, that's probably our recommendation. Like Barry said, it'd be nice to have our own test borings, if we're going to do anything with a vertical well, for sure. Barry could put those in. We would offer geophysical techniques, one being electrical resistivity and the other a passive seismic technique, which will give us a pretty good estimation of the total depth of the formation from the surface down to bedrock. And if there's an over-deepened area that we've somehow missed, it would be great to know where it is. And sometimes they do exist. We've drilled in plenty of places where we didn't have geophysics and missed a deep trough and then moved over when we had the geophysics telling us where to go and found a little over-deepened trough. And out here, if you get 5 more feet of saturated thickness, it's a lot more. So we would recommend doing some kind of geophysical surveys on the peninsula, see if we can find an over-deepened area, and probably lead from there into actual exploratory test borings to supplement even more the number of wells that have already been put out there, see if we can get more and actually have Barry look at the actual samples. We'd send them off to a well screen designer and see what they think is possible in these types of materials. And there are a lot of different types of well screens now that you might be able to get a little bit more efficiency out of the well screen. Long term, it's still going to take Barry to come out and develop them every 2 to 3 years probably, because the formation's not going to change any no matter what we do right around the well. So even if it's a more efficient well screen, larger diameter, eventually the same issue is going to happen. It's just a question of, redeveloping on a regular basis to keep up with it. Because we're just so limited in the available drawdown.
And this would take place within the existing footprint of the easement now, I'm assuming?
Yeah, we could, if that's an ongoing limitation. If it's possible to go beyond it, we would say absolutely, let's go beyond it. See if we can expand the footprint. Maybe we can get contributions from a greater area. Leakage through the lake over a bigger area. Basically, you're pushing your drawdown cone. The cone of depression is the hole in the water table that we create when we pump a well. And if you can get that to spread out further and further underneath more of the lake, then the lake will drain, literally leak into the formation that much over a bigger area. You'd have more water, over time. So anything we can do to expand the area is great. And a horizontal well could do that effectively, and more production wells can also do it. You just need more of them over a bigger area to make it happen.
Yeah.
And geophysics, just so you understand what that is, they drive a probe every 10 meters, and then they send a signal from probe 1 to probe 2, probe 1 to probe 3, from 1 to 4, then 2 to 3, 2 to, so then they can create a profile, and then with those signals that they get back, they can tell, roughly what type of soils are there, and, is this, a decent area? So they create a graph that's sort of a U-shaped,
Yeah.
And then they can tell where bedrock is and that type of thing. So it's very unintrusive if you're doing it. You're just going out there, putting stakes in the ground every 10 meters. So if the Cleveland would allow, we can, you could expand that above, your existing easement area right now and look without any problems. And then if something comes up, then you can talk about the next step. But,
Right.
Sherry, have you done the acid cleanings on these wells recently? Or have you videoed them at all? Is that beneficial?
We typically don't use acid. We just do mechanical surging and then chlorination afterwards to make sure everything's, there's no bacteria. And we have televised them in the past, a few of them, I'm sure.
Yeah, and the reason why I ask is to see if there's any buildup on the screens that can be, acid washed off. That's an idea of, I don't know how much that costs. Is that in the plan of assessing what you have currently versus before you go exploring, or simultaneously as you go exploring?
Yeah, I mean, we've not found a lot of clogging, I believe, after our cleaning process is completed, so it's not like something we do every year or every time we clean the wells, but certainly would be worth, yeah, been a while.
Yeah, it might be worth doing a camera survey of some of the wells to determine, are there issues in particular wells, or some of the wells doing better than others need a different type of cleaning. So, might be worth exploring a little more.
So I guess kind of the question that comes to, that would be presented and the commissioners had to decide, do you spend, I'm just going to throw out numbers, but do you spend $2 million on this well field to increase it 100 gallons a minute, or do you spend $8 million on another source, that you're going to have, just say 300 or 400 gallons a minute, and then you have two additional, your sources are in two different locations, which is, ideal. If you have everything all in Colby Point, if for something, something catastrophic happens to Colby Point pump station, it's like, you're kind of stuck. So having two separate supplies are nice. So that's kind of the question that comes up, it's going to come to you guys is, which way you want to lean on that, and what you think is going to be best long term.
Yeah, so, in looking at that, after we had talked with you folks a year and a half ago, the numbers that Mike had mentioned were, for a remote well opposite somewhere else than Colby Point, was in that $11 to $12 million range, and the surface water treatment was the 25 plus with treatment and so forth. Those aren't numbers that we have the ability to digest, period. It's, they're great options, but it's a system that has a $650,000 a year budget. And this Main Street project on our backs for 20 years now. So, that all has to be taken into consideration as to where you go moving forward. But I'm sure that, we'll talk about it as a board and see maybe what direction we want to go. The question's going to come to us, and I think while we have DES here, it's a good time to ask it, because some people have asked me, and my answer's been, I don't know. The issue that's going on in downtown New London with the contamination of the bedrock wells at where Continuum put in their well field. Is there any possibility that we're looking at contamination in what we do over on Colby Point? And if you don't,
there's no. The contamination is quite isolated to the downtown area around the New London Cleaner site. Yes, there was PCE detected in the two bedrock production test wells that were installed at the New London Hospital site for the New London Place development, but that was detected at one point, it was around 2 parts per billion, so it was above the detection limit. It was certainly enough to be contaminated, but it was not at a high level. And that location is a little over 1,000 feet from the cleaners, so it's adjacent to the site and down gradient. This site, Colby Point, is really far away, and there's lots of hydrologic divide, so groundwater is not flowing from the downtown area towards this. I mean, that is one really interesting part of this well field, is that you are a little island surrounded by the lake. So obviously these wells are dependent on the surface water quality, and it's obviously important to maintain the surface water quality of the lake, but they're not at risk of contamination from the cleaner site.
so on that same thought process, if the precinct was to be on the periphery of New London, looking at possibly putting in bedrock wells, would there be a concern there going forward?
Yeah, I mean, I can't certainly say yes or no. We did, I mean, I've been involved in these other two sites, is it the Twin Pine or Commons site also has wells. Some of them are pretty productive. Actually, the New London Place wells that did have the contamination, or when they were pump tested, they're actually very good performing bedrock wells. And same with the Twin Pine wells. The initial few they drilled were not successful, but I think they did end up drilling a higher yielding bedrock well at that site that has a deeper fracture. It's most likely not at all interconnected with the bedrock fractures that the hospital well has intercepted. So it's complicated, and we don't really know. There's a lot of uncertainty with bedrock aquifers, so there's always potential. But we could obviously do testing to determine if there's a potential for issues through water level monitoring. We do extensive water level monitoring and water quality testing. Those are the tools we have for disposal.
So you could imagine from our position, the concern would be if you were going to spend multi-millions of dollars and there was any chance that you could come up with a scenario where you might have contamination down the road, because when you have a small system well like that, where you're not pumping as aggressively as you would a municipal well. I mean, municipal well would pump a lot all the time, and whether that has anything to do with where you could get cross flows or again, that's a little beyond me, but it's something that is out there, and I'm sure that the voters of the precinct are going to have that question, before you were to try to even allocate any money to something like that. So that's the only reason I asked it. That's another little thing that's come up that has kind of muddied things a little. But
I can elaborate. In our report, we put in a secondary favorable zone for bedrock called LON3, and that's only about 2,000 feet south of the hospital site. We'd be concerned about putting a well there in that particular zone. We'd rather focus on the ones further to the south, LON1 or 2, which are our primary bedrock zones, because of the contamination. That would put up a red flag, but it's within 2,000 feet, you got to be a little more nervous.
Yeah.
But, we're talking a mile, probably a mile and a half to Colby Point, so there's no concern there, like Andrew said.
No, I was thinking more in the other bedrock well
Yeah,
fields also.
Sure.
Because the infrastructure and the cost of putting those in
I know, significant.
is a huge amount of money. And if
Yeah.
you were to come up
Sure.
with a scenario where, suddenly you had water that wasn't quite feasible for municipal purposes,
Right.
and you had to treat it somehow.
Yeah, so you go on the preliminary investigations to determine what the level of the risk is before you put in a hole.
Yeah.
Yeah, from our standpoint, probably the bigger risk is natural contamination from radiation. We know there's
Right,
a
we
lot
talked about that.
Yeah, there's definitely radioactive components in many of these granites, and so that's something you have to weigh also, not just the man-made stuff, but there are natural contaminants too you have to be concerned about. And bedrock wells are more subject to that, certainly, than Colby Point.
Yeah, and we'd have to have certainly wellhead protection areas for those well
Absolutely.
sites.
Yep.
And is it 400 feet, 800 feet?
400 feet.
So an 800-foot diameter?
Yep. It's about 11 and a half acres
Yeah.
of land for a high-yielding well.
Yeah.
Yep.
Not a lot of great options.
No, I agree with you there.
I think
You're in a
that
tough spot.
when the precinct was formed in the 20s, there were not a lot of great options. There's a reason they went 8 miles away to get water. Part of it had to do with gravity too, though.
Yeah, sure.
Do we have some things we could look at, Barry, out there, I think, maybe?
With respect to,
Maybe where we want to focus our attention, and maybe we talk with, or do we have maybe Emery and Garrett go out and do some analysis and see what we can do with the existing field?
yeah, I think that's maybe the first thing to do would be to just look at if we can come up with any of the old original construction logs of the what we're working with there. If not, then I would suggest we'd maybe want to do at least one test well and get some undisturbed formation samples, and just see if we could come up with a different well design that we thought might produce a little more, or be a little more efficient than what was put in, so.
I believe we have the original logs. I'm almost positive, I think it came out of your first report.
I'm pretty sure that
In the 90s.
I'm pretty sure that the construction logs were either in our report or in the DLMAR pump test report. I know they exist, and I think they can be found.
What are you talking about, the
Yeah,
civil analysis?
I recently scanned that original DLMAR report, so we have that.
They might have sieves.
Yeah, and did that have the logs? Did that have the construction logs?
I believe so.
Okay.
Well, we have those in our documents for each well.
Oh, we have it.
I think Barry's more like looking at the sieve analysis of the soils. And that's why you're
formations, yeah.
saying, you know, if you do a
Oh,
new
yeah.
boring now you're gonna have, you can do a sieve, and now you
Actual
can
material.
maybe, you know, are the screens different now? You can design a different screen and stuff that might be helping you.
I will say, I remember we did an analysis back then, because there was a lot of sieve analysis, and we looked at the sieves in order to compare the sediments to a slow sand filter, to prove to DES that a well on Colby Point was going to pull stuff through about 30 to 40 to 50 feet of a slow sand filter.
Right.
But what that means, slow sand filters have a very small effective size of material, you know, that's very fine. But, so the good news is you get great treatment.
Good
you know,
filters.
going through that. The bad news is it doesn't go fast.
Right.
Yeah, it's slow.
I guess all the information is great. I just wanted to mention one thing that, you know, Cotton's here, and no intention of putting you in any spot on this with respect to Colby Point. I wanted you to be as a concerned stakeholder to hear what was going on and what we were talking about. Because we talked about it and said, you know, it'd be great if Cotton was there so she could hear about it. And, you know, I think, you know, our easement allows us to do maintenance of the field and such. And, you know, I think we've had a good working relationship as far as communication and being able to get out there without infringing on the point and its activities. So listening to what has been said here, you know, the commissioners will talk about it, and we would come back to you folks and say, you know, if we were going to do a little bit more exploration within the field, you know, is that something that's plausible or whatever? So I just didn't want you to feel like you're backed into the corner, even though you are sitting over there near the wall. So if you had any comments, that would be great.
Thanks, Ken. So I do have some comments.
You gotta turn it on.
The way, it's green, thanks.
go.
There we go. So I come here as two people. One is Cotton Cleveland. John Garvey and I live on 159 Birch Acres, and we pay for water coming from the precinct. And the other is I'm the president, chief administrator for the Cleveland Company, Inc., which owns the 20 acres comprising the land called Colby Point on 195 Main Street, Springfield. The current owners are myself, my mother Hillary Cleveland, and my siblings, David, Lincoln, and Susan. So to the Water Precinct Commissioners, thanks for inviting me here to learn more about this really important subject and also to make a few remarks. And thank you for letting me do that. So I'd like to address three topics: leadership, wells at Colby Point, and water conservation. Regarding the wells, as you can imagine, regarding the Cleveland Company, I'm obligated to check with the owners on any policy matters, such as new wells at Colby Point. We have not yet been approached by the Water Precinct regarding this option. However, given that our parents, Jim and Hillary Cleveland, gladly participated in helping fulfill a great community need, I said in the 60s, but obviously it's the 90s. I totally stand corrected on that. Agreeing to have the I'm getting so old now I can't quite remember which decade, agreeing to having the 6 wells drilled on this special land. And if there is an urgent and compelling need for water, I'm sure the family would give this question thoughtful consideration. The original wells were installed in such a way as to minimally disturb the fragile land on Colby Point. In fact, when you walk, as you've said, when you walk on Colby Point, it's difficult to see where the well caps and the electric charging tubes have been placed. If the Cleveland Company were seriously approached with a request for more wells, we would need assurances that the modern well digging would have the least possible impact on the landscape, and we would want to consult with the Society for Protection of New Hampshire Forests, which holds the conservation easement on the property. Regarding water conservation and clean water, the family feels very strongly that the precinct, the towns, and all citizens should be practicing rigorous water conservation. If asked to support new wells or wells at Colby Point, we would need detailed, agreed-upon assurances that the precinct, the towns of New London and Springfield, the Department of Environmental Services, and all businesses and residents are committed to practicing water conservation going forward. This would include agreements with whatever, Twin Pines, New London Place, or any other new construction plans going forward. It would start with the precinct measuring the amounts of water each customer uses, providing a range of water usage that's acceptable for each category of customers, and developing some kind of incentive or discouragement, payment penalty if the water use was in excess. It would require the towns to adopt rules when gardens can be watered and encourage the use of recycled or gray water for watering lawns and gardens. The state and towns and precincts could offer incentives for things like installing low-flush toilets and any other water guzzlers. And you all know, and you can read, many, many communities in the Southwest and who are out of water have really, really reduced significantly, 30% sometimes, 40%, their use of water this way. Additionally, the precinct would need to develop transparent standards for how and when new housing is going to go on the precinct water. Lastly, DES and appropriate parties would remediate the current contamination of water near the cleaners so that people who are not able to access precinct water can drill wells and access clean water, thus alleviating demands for precinct water. Regarding leadership, so with my citizen hat, and I'm not talking about leading the Cleveland Company now, but I am urging the leadership in this room, all of you, right? You're all here. And if you're not, I've got a copy of this for you. To take a proactive approach to solving our current and future water needs, as well as our workforce housing needs. A strong, enlightened leadership position from the precinct, the towns, the state, and all our businesses and citizens would look at the combined goals of water usage, water conservation, and workforce housing to move forward together. And on a personal note, I can't help this. In addition to forest and land conservation, water conservation, and cleaning up contaminated lakes, ponds, and rivers, one of my father, Jim Cleveland's, strongest local interest was in developing workforce housing and lower economic housing. He fought hard to get Bittersweet built for the benefit of economically challenged elders. Towards the end of his life, he planned a manufacturing housing development in New London so that young policemen and women, firefighters, teachers, EMTs, nurses, and others could afford to live in this town. Sorry. He died too soon to see his vision come true. I'd like to think that the Twin Pines project would meet his approval and that he would want the precinct to approve water for this important addition to New London. I know he would applaud water conservation efforts, given the current and future needs of the community. So I know from family experience that change is not always easy. There were good people in this town who strongly resisted the building of Bittersweet, strongly resisted this. There were good people who strongly resisted the wells on Colby Point. But both projects, as you've seen, make New London better today than it was back then. And we need to move forward to make New London better tomorrow than it is today. Thank you for letting me speak. And Ron, I've got that for you. You need that?
Was there any other thing you needed to add to this, or?
Well, I could,
Questions we digest?
I'll offer, I think we can put together a proposal looking at geophysics, the SCADA system, just try to put everything together that a hydrogeologist really needs to do a further evaluation, I guess. I think we can put that into some kind of a proposal, and I can work with Barry. We work together on a lot of jobs, and try to figure out what we might be able to do with the existing wells, and what would we do with a new well? You know, is there room, or do we just don't recommend it, or can we recommend it? So I think we can work together to put something together, a plan for the next step of action out there, if you want to try to maybe get back to the capacity, or at least increase it a little bit. You know, it's not going to be a huge increase, but I think it's possible.
Yeah, I would just ask it, with a proposal like that, if you could put some kind of a timeline to what you anticipate these activities would take, it would just be helpful for us to understand it.
Yeah, absolutely. We should be able to figure out which step can happen when and what order. Yeah, sure.
So there are funds available from the state to do strategic planning, which I would consider what you're looking into, strategic planning for the precinct. We recommend you look into that as a source of to help fund the ongoing investigation.
We actually did, and did not get it.
There's a new round upcoming. November 15th.
Are those the $50,000 strategic planning grants?
No, they are $30,000 strategic planning grant with a 50% match.
Oh, it's gone down, okay.
Move forward. Thank you, everybody. Commissioners have one more item that they're going to deal with. It's regards to the construction on Main Street.
Thanks, Drew.
Sign off on it. Other than that, this meeting.
See you, we'll talk later.
Thank you for coming, everyone.
Mike and Jackson. He had surgery yesterday. Yeah. He's in rough shape. I haven't got the story yet. They haven't been around much. Those are handouts.
Say hi to Barry.
Good guy.